Here's 29.5. A particle mass 2 milligrams, charged minus 6 microcoulombs, moves in a positive direction along the x-axis with a velocity of 3 kilometers per second. It enters a magnetic field of 2I plus 3J plus 4K millitesla. What is the acceleration of the particle? Now, since we're given the velocity and the magnetic field as vectors, and we're not given the angle between them, we can't use the short version that we normally would like to use, namely F equals QVB sine theta, because we don't know what theta is. So we're rather forced to use the vector form of this equation. Force is equal to Q velocity crossed with magnetic field. Alright, let's see how this works out here. We have charge, negative 6 microcoulombs, times the velocity, which is 3 kilometers per second, so that's going to be 3 times 10 to the 3 meters per second in the x direction, or I, and that is crossed with the magnetic field, which is 2I plus 3J plus 4K millitesla, so that's 10 to the minus 3 Tesla. Alright, let's put all of our numbers together. We have negative 6 times 3, and then we have a 10 to the minus 6 times a 10 to the 3 times a 10 to the minus 3, and then what we're left with is I crossed with 2I plus 3J plus 4K. Alright, 10 to the 3 and 10 to the minus 3 cancel out here, and we get negative 18 times 10 to the minus 6. I crossed with 2I is going to give me 0. I crossed with 3J will give me a 3K. And I crossed with K will give me a negative J. So that's going to be a minus 4J. Okay, so there's our force. We want the acceleration. The acceleration will equal the force divided by the mass. So that would be this, and we want a vector acceleration. And so that would be this negative 18 times 10 to the minus 6, 3K minus 4J over the mass, which was 2 milligrams. So that would be 2 times 10 to the minus 6 kilograms. We have a 10 to the minus 6 and 10 to the minus 6 cancel out. Negative 18 divided by 2 will give me a negative 9. So this would be a negative 9 times 3K minus 4J. If I multiply the negative 9 through, I'm going to end up with 36J minus 9K. Or I'm sorry, 27K. 9 times 3. And that will be all in meters per second squared. So we have, that's our final answer, 36J minus 27K meters per second squared is our acceleration of this particle.